Hi, I'm Olivier Siberio, CEO of Sensin. Last year, with the support of the California Blueberry Commission, we started a project to calibrate Nutri-Scope for nutrients measurements in blueberry. That project is now well underway. We have built a strong network of participating growers, and we are collecting samples across California, and our technical team are starting reviewing the data. For this new project, we would like to build on that work and add another important piece of information: plant health. With the first project, we are essentially trying to answer the question, what nutrients are present in the plant? With this project, we want to complement that information by asking, how is the plant actually really functioning? So to do that, we propose to calibrate Nutri-Scope for 5 plant health measurements: pH, redox potential, Brix, electrical conductivity, and chlorophyll. But before I go further, let me quickly show how Nutri-Scope works in the field and what a measurement actually look like. So let me share my screen. Voila. So the way it works is actually quite simple. You take the leaf you want to analyze. Alors, it's a non-destructive scanner, so you don't need to take off the leaf like I just did here. You can measure directly in the plant. So you select the leaf you want to analyze, you open the scanner, you clip the scanner, and using your phone, you launch a scan. So one scan usually takes something like 10 seconds. However, we ask the user to do 15 scans in the field before getting to the nutrients. That way, we kind of reproduce the process of collecting multiple leaves for lab analysis. And voila, after these 2-3 minutes of scanning time, the first screen that you have access to is the list of the nutrients. So this is the first project what we are currently doing. So here in the case of wheat, which is a model that is already established and calibrated, we have like 16 nutrients available. We don't know if in blueberry we'll have 12, 13, 16. That will be an outcome of the project. But you will have the main nutrients like nitrogen, phosphorus, potassium, and some oligoelement, ammonium, copper, boron, etc., etc. Now, the second screen is very relevant to our project. This is plant health. So in plant health, we measure a couple of parameters, so pH, Brix, redox, conductivity, and chlorophyll. And I'll talk a little bit more about that after, but the green curve here is our stress index, which is an aggregate of pH plus redox that measures the overall level of oxidation of the plant, which means how stressed the plant is and how the plant will be sensitive to pest and disease. So voila, as you can see, the measurement itself is very simple and can be done directly on the plant in the field in a non-destructive way. So the work behind this project is to make sure that the information produced from that scan is accurately calibrated for blueberry. As I mentioned, 2 of these measurements, pH and redox, are particularly interesting when looked at together. We use what we call the pH redox framework. It gives us a way to represent the physiological condition of the plant based on its proton and electron activity. From pH and redox, we can also calculate our stress index, P plus pH, which gives us a simple way to follow changes in plant physiological state over time. The objective of this project is to calibrate these measurements specifically for blueberry. We don't want to assume that what we have learned from other crops like wheat apply directly to blueberry. We want to build the calibration from actual California blueberry data. The field campaign will be quite straightforward. We will recruit and train a dedicated 2-person field team. They will travel to participating blueberry farms with Nutri-Scope and a portable calibration kit. For each sample, they will first scan the leaf with Nutri-Scope and then measure pH, redox, Brix, conductivity, and chlorophyll using conventional reference instrument. We are targeting approximately 600 samples throughout the growing season across different farm varieties, environmental conditions, and plant conditions. We will start with a network of growers established through our first CBC project and expand that network as needed. Importantly, the burden on growers will be very limited. We primarily need permission to access their field and recommendation on where to do the samples. Our team will do the measurements and collect the data. At the end of the season, Sensing will provide the machine learning work as an in-kind contribution. We will use the field data to train and validate 5 blueberry-specific models and integrate the models that meet our validation criteria into Nutriscope. Ultimately, the two CBC projects are complementary. Nutrient calibration tells us what is in the plant, while plant health calibration helps us understand how the plant is functioning. Putting those two pieces together can give California blueberry growers a much more complete and timely picture of crop conditions directly in the field. I really want to thank you for considering our proposal.